Hello everyone, welcome to my tutorial video, and today I will show you how to do an independent sample t-test using SPSS. Without any further ado, let's get started. So, what is a t-test? A t-test is a statistical test used to determine if there is a significant difference between the mean or average of two groups or participants. For example, you could use it to compare the test score between two different classes, or to see if there is a difference in reading comprehension between male and female students. For this tutorial, we want to see if there is a difference in writing achievement between two classes, class for X and class for Y. In this case, our group variable is the class. We call the independent variable. The score we are measuring is writing achievement is our test variable, which we call a dependent variable. As you can see on your screen, I have my data ready in Excel. The first column is our group variable, the class, and the second column contains the score for writing achievement. Let's copy this data and paste it into SPSS. Alright, in here you have two options of pasting. The first is normal paste, and second is paste with variable name. In here, I will show you what happens if we use the normal paste. First, let's paste it. In here, you see the data have class and variable in the first row. If you use this method, you need to remove the first one and then clear, and then go into the variable view. In here, we need to collect the variable data first. Like we give it name, and in the second variable, I'll use WA, the shortened form for writing achievement. In here, you have three ways of naming your variable. The first is the shortened form. The second is using capital in between the word. And the third is by using underscore. Next, we go into the type. In this type, for the writing achievement is wrong. It's not a string, it's numeric. What happens if you use string instead of numeric? We can go into the measure, and you see there is only two options, ordinal and nominal. To fix this, we can go into the string, click these three dots, and change it into numeric. Alright, now let's give the label first. The class, I'll just use class. And for writing achievement, I will write the full name. Right. As for the value, we do not need to put any value in here, unless if you are using the group like using 1 for male and 2 for female. You use that kind of data, then you need to enter the value in here. For the missing, we can skip this, column skip, align skip, and for the measure, we need to make sure that the writing achievement is correct, because writing achievement is considered as interval. We need to change nominal into scale. Great, our data is now ready. The next step is for any analysis is to state our research question and hypothesis. Our research question is there any significant mean difference in writing achievement between class 4X and class 4Y? From this, we can create two hypotheses. The null hypothesis, which states that there is no significant mean difference in writing achievement between class 4X and class 4Y, and alternative hypothesis, which states that there is a significant mean difference in writing achievement between class 4X and class 4Y. Before we can run our t-test, we have to make sure our data meet two conditions or prerequisite tests. We need to test for normality and homogeneity for variance. And how to do that? First, for normality, you can go to Analyze, Descriptive Statistic, and then go into Explore. You will meet with this kind of option. First, we put class into factor list and writing achievement into dependent list. Next, go into this plot, and then you check it for histogram and normality with protest. This is important because you want to know whether your data is normally distributed or not. For histogram, it's used to visually prove that our data is normally distributed or not. And next, for fit versus level with Levin test, we can check for power estimation. This is important because if you do not check this power estimation, the homogeneity test will not appear in your outline. Okay, now let's continue. Alright, now that we have our output in here, you have two ways of navigating. The first is by scrolling it normally. The second is to use or click the output tree in here. Let's go into the descriptive. In here, we have the descriptive analysis of our data. In here, for the class 4X, the mean is 56, while in the class 4Y, the mean is 54. In here, we can see that the class 4X have a better mean compared to 4Y. Let's look at the standard deviation. The standard deviation for class 4X is lower than the class 4Y. There's also different. Let's look at the range. The minimum for the class 4X is 29, while the maximum is 96. The range between this minimum and maximum is 67. And let's look at the class 4Y. The minimum in this class is 25, while the highest is 96. The difference between minimum and maximum is 71. There is a difference. But to prove that there is really a significant difference, we have to go into the last step, which is the hypothesis testing that we will do later. Now, let's look into the test of normality. All right, in here we have two different type of normality tests, Kolmogorov-Smirnov and Shapiro-Wilk. Shapiro-Wilk is normally used when you want to compare between two groups that have less than 50 samples. Meanwhile, for Kolmogorov-Smirnov is usually used when you have more than 50 samples. Because we have more than 50 samples, we use Kolmogorov-Smirnov. And how do we know if the data is normally distributed? In here, we see the sig comma, or we call signifier or p-value. For normality test, if the p-value is greater than 0.05, your data is normally distributed. If it's below 0.05, it is not normally distributed, and you have to use Spearman method. Because our data in here show that it's 0.200 and it's greater than 0.05, our data is normally distributed. And to prove that, we can see in the histogram, we double click it and go into this option, show distribution curve. We click it, and in here, we can see the curve in here shaped like a bell, which means the data is normally distributed. Or you can just see on the top right of your screen, it say that it's normally distributed. So let's go into the class 4Y. We repeat the step, double click, show the distribution curve. It's also the same. It's shaped like a bell, and on the top right corner, it's show normal. So we can assume that our data is normally distributed. Now we can move into the next step, which is the homogeneity test of variance. In here, the one that we need to look for is the based on mean, because the one that we need to know is the mean. Because like the first research question, we want to know, is there really is a significant mean difference between two classes? So in here, the p-value is true 1, 1. If the p-value is greater than 0.05, then our data is homogeneous or equal. After we know that our data is homogeneous or equal, we can go into the last step, which is hypothesis testing. And how to do that? Let's go into the analyze. We go into the compare mean, and then we select the independent sample t-test. In here, you need to input the class into the group variable. And here you have to define the group. Because there are two groups, the 4x and 4y, we just need to put that group in here, 4x and 4y. Continue, and then for weighting achievement, we put it into the test variable. In here, you do not need to do anything else more. You just need to click OK. Alright, in here, we have the group statistic. In here, you can see the first class have 63 students, while the second class have 61 students. And the main difference between the two of this group is slightly higher on 4H. And the standard deviation, the 4H has a better standard deviation. For now, we can see that the class 4H is better than class 4Y. But to prove that there is really a significant mean difference, we have to look into the independent sample test. This table is our final result. For interpreting the result, there are two steps that we need to do. The first thing is to look at the Levin test for equality of variance, or the homogeneity. Because we pass the homogeneity test, and the result is the data is homogeneous. That means we use the equal variance assume for this step. And here, we need to look at the signifier to tell. If the data or the p-value is greater than 0.05, then we fail to reject the null hypothesis. But if the value is less than 0.05, then we successfully reject the null hypothesis. Because in here it shows that the value is 0.542, that means the p-value is greater than 0.05, which means we fail to reject the null hypothesis. So, what is our conclusion? Since the p-value was greater than 0.05, we conclude that there is no significant mean difference in weighting achievement between class 4X and class 4Y. Now you know how to correctly perform and interpret an independent sample t-test in SPSS. Thank you for your attention and goodbye.